Wait for the connection notification, which seems to be happening. I'm being told excellent connection, absolutely excellent. Let me get the URL. The Uniform Resource Locator. Yeah, I think that's what it's called. Uniform Resource Locator. Okie dokes. Now, oh, it's 1 o'clock in the morning. That's just ridiculous. But that's okay. I have absolutely no regard for the clock, and I've also noticed that my clock has stopped. The clock has stopped. It only took 5, 6, or 7 years. Hello there. There you go. Marcin, you are fantastic. Without a doubt, you have the fastest response. Thank you very much. I did try to clean up audio a bit. I'm trying to reduce background noise, but I got servers running and stuff. So there's always going to be that background hum of some servers. Occasionally there may be hard drive thrashing noises, and what are you going to do? You know, what are you going to do? Right? Okay, just a second. I'll be right back. I'm going to go fetch a beer. And I have cut way back. It's been at least, what, 3 or 4 days since I saw a beer. I'm going to go fetch one right now. Be right back. While I'm at it, I'll see if I can find a battery for the clock. The clock on the wall has stopped. It's stuck at 8:45. It's not a very useful clock. Well, it's going to be right twice a day, you know. And I know it's like one of those things where you always have batteries set aside somewhere, but you have no idea really where they are. Yeah, maybe the heck with the clock, and we don't really care. Let me go get a beer. Okie dokes. So this is a follow-up, Marcin. This is a follow-up, kind of a follow-up video with not really a whole lot of purpose. What I want to do, I think I'd like to figure out a way to do somehow, I don't know how I'm going to do this, like a 1 hour video. A 1 hour video where I take a fresh install machine, Linux, and get the latest Linux kernel and build it, and somehow get that all done in 1 hour. You know, while hand waving and maybe having a beer or two, but you know, ran into problems yesterday. There are some dependencies some software packages and dependencies that you really need in order to build a Linux kernel. And it's not exactly documented much of anywhere. If you haven't gone through the experience of trying to figure this stuff out over years, then, who do you go to? It's not like as if anybody documents this process. Maybe I should write an article on that. Write an article and post a video, but I'm going to have to do it like a cooking show. You see, anytime you watch a cooking show, the chef will be saying, and now we're gonna caramelize these onions, and we're gonna begin to render out the fat out of this bacon, and we're gonna, and you do that kind of stuff. But you're making beef bourguignon, and beef bourguignon requires hours and hours and hours to just cook at a bubbly sort of low temperature, medium heat, like medium low heat, but it's hours and hours long. Just like a Linux kernel on most average hardware, it takes hours to get that done. So making a video where I get that all done in 1 hour, that's going to mean I'm going to have to do like that chef trick, or worse, and this is going to be frightening, worse. I'm going to have to edit. Yeah, edit. You watched it twice? Oh, no, that one's staying around forever, Marcin. I've gotten some that's good English. I have received a little bit of feedback, some critique, constructive criticism, wherein some good people have said to me, and this is what you can confirm this, but no, that other platform is gone. Let me finish this sentence here with Marcin. What I was told is, I take it for granted, or I make the assumption that a lot of the stuff I'm doing is pretty much common knowledge. Like, people just know this, right? So there's no reason to leave a video, long hand waving, ranty video like that on YouTube, because it's kind of like a waste of people's time. And then I've had other people come back to me and say, you can't learn this stuff anywhere. Like, nobody teaches this stuff. And I'm hearing from our friend in France that even in some of the educational institutions that he's currently dealing with Linux and Unix and networking, the instructors are completely incompetent. They just don't know what they're talking about. And that's sad. That's really sad, because from what we've heard from our friend in France, Mosh, with Jazz the Cat, is that there's practically rebellion on the part of the students, because you can fool some of the people some of the time, but you can't fool all of the people all the time. And an instructor who really just doesn't know what they're talking about, they don't last very long in front of people that are asking like actual questions, like, what do you mean by a subnet? What do you mean by a bit mask, which is used to isolate the bits that are changing? Like, this is IP version 4 TCP/IP. What, some of those bits can change, and some of the bits are a locked subnet. And if all the bits are 0, you can't use that. And if all the bits are 1, you can't use that. That's a broadcast address. What does that mean? Apparently, that's just not information that's taught. Unless you work for Cisco. If you're a Cisco person, Cisco certified network administrator or network engineer, you know what you're talking about, And those people cost money. Those people are worth real money. Okay, so I'll try not to delete stuff. Okay, let's get to the Linux kernel. We just go to kernel.org here. I'm just doing a bit of a follow-up. So there it is, 516 RC4. That's a release candidate. These are called stable, but 514.21 is called end of life. End of life, but stable. November 21st. Isn't that interesting? 515.6, that's considered, stable. What was I saying about the other platform? Yeah, I'm not there. I'm not there. Never again. In fact, our friend Nico, who was streaming on that other platform, he got banned for 30 days because he had this IRC channel that you're using right now. The IRC channel you're using right now is public. It's fully public. It's, hosted at libera.chat because the previous platform, which was Freenode, exploded, and then it played Russian roulette with 6 bullets and shot itself in the head because stupid people did stupid things to Freenode, and they destroyed it. And at Freenode, the Blastwave channel was there for 15 years, 17 years, since I think since 2003 or 2004. And then Freenode exploded, and so, everybody jumped ship and went to Libera, right? And yeah, the fascists, there's a story. Let me show you. Instead of me telling you, let me show you, because Nico, of course, he's got an account on various servers and on things. He's got access into my data center stuff, and, let me just show you, because there's no way, we have to laugh about this. We have to laugh. It's too stupid to be believed. So, he got banned for 30 days because someone issued a complaint to Twitch, right, saying that he was sharing personal information that could be used to locate or financially damage another person without authorization. Well, how is that possible? I mean, I'm Dennis Clark. Everybody knows my name. I've basically been Blastwave, on the internet for the past 2-3 decades, right? Been involved in, IBM projects with Sun Microsystems projects with Oracle up until they got all upset and crazy. Projects all over the place. I mean, it's not like my name isn't public. I mean, I've got bug reports in the Linux kernel, the Apache Software Foundation. I'm involved in the FreeBSD Unix. I got my hands into all kinds of projects all over the place, including things like Python. And I'm taking up an interest in Rust. And so my name is not an issue. This channel, Oracle went completely insane. Oracle shot themselves in the head. They took all open source projects and they basically just locked them down. Took all the code, locked them down, and there's only a couple left. Like MySQL, I think they're still releasing source code to MySQL. The firewall stuff, which is IP filter, Darren Reed is the guy who created that stuff. And Darren Reed always made sure that IP filter and the firewall technology that was, implemented into Solaris Unix, all that stuff was open source and free. Oh yeah, they shut him down. They shut him down. They went after websites like We Sun Solve, which is basically a documentation community website where people were sharing, oh, we ran into this problem, this is how we fixed it. Oh, you're using this kind of storage array or using that kind of networking, and people were talking and using this website. Oracle sent lawyers after them and shut them down, saying it was confusing their customers. I mean, that was their argument. Their argument was, yeah, you're confusing our customer base. Our customers are going to you for help as opposed to us for software service and maintenance contracts. And then they came after me, the Blastwave project. They came after me. I mean, they just went, Oracle went insane, insane. And they don't care. So let's not worry about whether or not I've been on the internet before. My name is out there, my email address is out there, my address is out there. This guy here says, why are you streaming Blastwave's channel? Are you stupid? That's a private channel. I'll report you for revealing private information. And then he did. And he got banned. Yep. Anyway, you can see that stuff. You can look at it yourself, okay? It's there. It's just sad, right? It's just sad. But, there's various different things. I think Nico's updating the documentation on this too. Yeah. In any case, yeah, so that other platform, forget it. Yeah, gone forever. Let's go back to reality. Let's go back to reality and reasonable stuff, okay? Because it's been 15 or 16 minutes, and I've got nothing done. I got a beer. That's a good thing, got a beer. Okay, so 5.16 release candidate 4, it's not considered stable, it's just a release candidate, but you'd be amazed how well that stuff can work. What I did was I fetched in the kernel into this machine. There it is, 5.16 RC4. And last night in the video link is in the description. I can't believe I'm doing a YouTube video where I've got a video link in the description. So Marcin, this video is not going away, all right? It's not going away. So what we did, I went into USR local source, and there's 5.16. I also looked at 5.15.6, which is stable, right? Let me just go up to, 5.15.6. I thought, yeah, maybe, but just for fun, we'll build the release candidate, RC4. Let me go back, click, click, click to these other machines. So 5.16 RC4, that's in the source directory, USR local source. In the build directory, well, in the build directory, there it is, December the 7th, 10 o'clock, Greenwich Mean Time, or UTC. From 10 o'clock to 2.5 hours later, okay, is what it took to get the kernel built with multiple mistakes being made on purpose, on video, okay? Oh, hi there. That's a good question. That's an excellent question. That's not a derail. Hi there, Dennis. Hi there, Zoot. Zur. Not to derail, could you clarify the difference in a module which is compiled into the kernel versus a loadable module? And I imagine you gain a performance boost with the former. Okay, let's deal with the first part of that particular question. We're going to break that question up into two parts. You ready? Okay. Part number one is, what do we mean by first off, let's talk about what we talk about a kernel module or a I want to reverse that. Let me just change the words around a little bit. I'm gonna make reference to Tannenbaum, and I'm gonna make reference to Unix, and I'll make reference to Linus Torvalds here. A kernel is a fairly complicated piece of software. No matter how hard you try, if you try to create your own kernel from scratch, what you're doing is you're creating a piece of software that will execute on a machine architecture using the machine instructions that are native to that particular architecture. It doesn't have to be portable at all. You can make a kernel which is for specific, like a specific kind of machine, right? And the question that has to be asked is, do you build now you're sitting down, I'm glad you asked this question because I want to address it in kind of a hand waving with, I don't want to get technical, but I want to address the question. It's an excellent question, world class. Do we build a kernel for a given machine such that that machine runs and we have access to memory, we have access to storage devices. Storage is not just memory. Memory, by the way, is storage. Memory is storage because it's outside of the CPU, the central processor unit. There's also memory inside the central processor unit, and we call those things registers. Those are processor registers or processor internal memory. There's an actual internal memory bus and data bus and all kinds of stuff going on inside a processor. To do like bulk storage outside of the processor, we need access to memory, which means we're probably going to need access to memory management hardware. Memory management. Possibly access to things like cache, memory cache, because sometimes we're going to fetch memory into the processor 1 byte at a time, maybe 4 bytes at a time. Maybe we need access to an entire page of memory. Now on itty bitty little cheap x86 hardware, that's 4,096 bytes, that's 4K. So maybe you want to fetch in 4,096 bytes all in one shot, but you've got no place to store it inside the processor. But you do have access to memory management hardware that you can communicate with. That is to say, the processor can communicate with hardware for managing memory. So you have to write a kernel that executes and runs. It's a piece of software. It executes and runs on your processor, on your machine, and it has the necessary intelligence or software components to, are you ready? This is, you're gonna use a word from the 1950s. Interface and interact. To interface or to interact and communicate with outside hardware, which is outside of the processor, we need specially written software components to do that. Now, there's two different ways of taking that approach. We can write a kernel which is called monolithic. Monolithic means like a monolith in 2001 Space Odyssey, it's one brick, solid, one thing. There's no indivisible components that get loaded in or get offloaded. It's monolithic. A monolithic kernel means everything you need is in this one piece of software to run the entire machine, to do the kind of duties and tasks that you need to have it do, and the software needed to interface, interact, and communicate with memory management hardware is all built into the kernel. That's called monolithic kernel. Another alternative is that you can have a kernel wherein you're going to interact with and interface with different pieces of hardware like memory management, or possibly with a disk or hard disk drive controller. But maybe you don't need that all the time. You only need that when you need to write information out to disk drives. Maybe you only have to do that once every, 60 seconds. Maybe you only have to do it once every 5 seconds. You got to remember, when you're talking about computer hardware that runs millions and millions and millions of operations per second, a single second is a lot of work. A lot of things happen. And maybe you don't need to deal with the disk drive. So it's possible to create something called a modular kernel. A modular kernel, unlike the monolith, it has a central core execution chunk, and then it has the ability to bring in or to load in a module of software which is specifically written to interface with, interact with, and communicate with other types of hardware. Or possibly you can have modules that do different operations. You might have a module of software which is written to do cryptographic operations. You only need them sometimes, which means you can load in this module of software, use it, and then when you're done with it, you can kick it out of memory and say, I don't need that now. I'm done. I'm now going to go forward. And that's called a modular kernel. So a modular kernel can load in and offload components of software that maybe you need sometimes. Maybe you need some of it all the time. And that raises the question that comes up in the second part of your question. The second part of your question was about performance. Let's not get all tied up in performance. Let's get tied up in functionality. God, I hate using that word. I sound like such a consultant, don't I? Don't I sound like a consultant? Functionality. Yes, call the 1-800 number at the bottom of the screen so that you can enhance and embrace the absolute functionality of a modular kernel. Yes, we can. Screw that. Look, what it comes down to is, it's not about performance, not really. Chances are that you have a particular machine and it's got certain hardware in it which is really essential. And you're going to be using it all the time. It's really critical stuff. So what you can do is you can make the decision. Now, the example that I've been using is memory management hardware. Getting access to things called memory cache. Be able to do things like cache line invalidation, being able to kick out pages of memory from out of nearline cache, how to access main bulk memory, which these days is billions of bytes of memory. To do all that stuff, pretty critical stuff, that stuff, instead of making it a module, we simply build it right into the kernel. What we get out of that is ease of use, the functionality, the function, the capability is always going to be there because you can't unload that software either. You got to remember, if it's a modular kernel, you can load in modules, but you can also offload them. You can kick them out. Say, nope, don't need that anymore. You can't do that with a monolithic kernel. So the Linux kernel is actually a bit of a hybrid. In some ways, we can build in components right into the Linux kernel, and those kind of situations you might say, well, doesn't that make the Linux kernel monolithic? Because you now took things that were modules and you built them right into the kernel. And the answer is, yeah, kinda. But you still have the ability to load in modules if you wish. But you're asking a fantastic question, because guess what? We can build a Linux kernel where the modules are built right into the kernel in a monolithic kind of style. And we can even disable modular kernel functions entirely. We can disable the modules. We can actually build a Linux kernel that's monolithic. Ponder that. Have I answered your question? Let me demonstrate. Let me demonstrate. LS mod. So LS mod, well, there's LS. So LS is like list, right? LS mod is list my modules. And there they are. Button. There's a module called button, right? There's a module out there. There's usually some of these are pretty simple. There's AMD GPU right there. There's a module. You know, this stuff, you know, the size of the module. Let me see, libaes, which is cryptographic functionality. That's a module. These are modules which are loaded in, that is to say, they're brought in after the fact. Some stuff you can build right in. Okay, I can tell that I bored the hell out of anybody who was listening, but that's, I think, pretty critical. That's a really great question. It's a really great question. But you're raising a fantastic. Let me just go to lib modules here. And remember, tonight I have beer. All right. Tonight I have beer. Okay. In this directory path, lib modules, this is where we find the kernel objects, the actual module software. And I should try to go find, let me go find something. Well, Watchdog, I want something simple. Oh, PC speaker. There's a classic. PC speaker, the ability to go beep. Just a second here. Find under 5.10. Type is file grep PC speaker. Well, there it is. It's a kernel object. That right there is, check it, says it's a 64-bit, least significant bits, little endian. It's a little endian 64-bit relocatable x86 piece of software. Not stripped, which means we can actually do debugging. And there's information in there. That file right there is a kernel module. Right there, PC speaker. That's in 5.10. Yeah, but that's not what I'm running. I'm running 5.16. So does the same file exist for 5.16? Well, we know it exists because it's currently loaded, right? Kernel drivers, input miscellaneous. I wonder how much stuff have I got there. Not too much. Not too much, but there's the PC speaker right there. You know, I think I kept it relatively lean. There's all the kernel objects for various, Atlas buttons. I don't even know what Atlas buttons are. I have no clue. Atlas buttons. Never even thought of it. What do we got over here? Let me just see. Oh, it's about the same list. From September 30th, December 7th. Just a second. Drivers. Let's just take a look here. So we've got all kinds of stuff here. NVMe. That's like storage stuff, right? SoundWire, FireWire, all kinds of stuff. That's in Linux kernel 5.10.0, provided by, Debian or Devon or whatever. Wow, the first beer is really hitting me. Let's take a look at 5.16. Let me see. Drivers. It's a different list. Do we have FireWire? No. No, there's no FireWire. There's firmware right there, but FireWire, nope, that's missing. What about NVMe? NVMe right there. No, it's missing. It's not there. In fact, there is lots of stuff in terms of drivers or kernel modules in the kernel that I built, 5.16. There's a lot of stuff that I simply kicked out and said, nah, we don't need any of that stuff. I mean, I'm surprised I see Thunderbolt here. I'm really surprised I see Thunderbolt. Pretty sure I turned off Thunderbolt, but looks like it's in there somewhere. That's weird. I thought I got rid of Thunderbolt. Whatever. Now, having done all that hand-waving talk, there is something I wanted to do. Yes, our local build. All right. I got a README file here showing things that I did to build the kernel, but it's not really a helpful README. It's not really helpful README. There's something missing in this process. Right, we had to keep installing software. Over and over again, I would hit a problem where something just wouldn't work. Right, and as a matter of fact, I think the very first kick at the cat, there it is. The moment we started the build process, it ran for 7 seconds. I remember, it's in the video. It's in the video. I said, I don't even think this is going to last for 20 seconds. I don't think it's going to make it 30 seconds. And I was right. It lasted less than 8 seconds before, boom, it blew up. And said, oh, there's a header that we need. We need libelf.h. We need that header. And then somewhere else down here, it also made reference to SSL. OpenSSL development headers. So we were missing stuff. There it is, 7.4 seconds. Yeah. Huh. And I did that on purpose. I did that on purpose in the video so that people could see when you go into this process first time, you have to expect to run into little hiccups like this. So how did I fix that? Well, the easy thing is just install the software packages that provide what you need. Trust me, they exist. This is building a Linux kernel. It's not like we're building something bizarre and strange. It's the Linux kernel. It's gonna work. Thankfully, in var log, there's a place called apt. Every time you use, what does apt stand for? Does anybody know? Advanced Package Technology, apt? I can't remember the last time I even asked. It just says command line interface. That's all. Command line interface right there, apt. Not exactly a good name. It's the command line interface for package management system. Okay. I'd like to think of it as advanced package technology, and I can't call the man who came up with the name. because he's dead. You know, another person lost. But we do have a log file right here. There's the history log file. And if we just look at, say, you know, the last 100 lines of that file, it's going to show us stuff that was installed. As a matter of fact, from the command line, all this stuff up here is being done by the installer. That's the installer that's set up like the operating system. And then right here, command line, right there. Advanced package tool, you looked it up, thanks man. I thought it was advanced package technology. Advanced package tool, thanks man. Yeah. Let's not worry about curl, but right there. This shows, you know, after install was done, we can see that on December the 6th, you know, late in the day, I was doing the install of this machine. And then took a nap, whatever, you know. About 6 hours later, 7 hours later, I decided to install curl, because curl is magnificent and wonderful and everybody should have it. So I did curl. Then I put in some very basic utilities that I think are essential to any decent Linux or Unix system. These are essential components, and I find it somewhat frosty and bothersome that it's not in by default. Let me just grep for command line out of that file, okay? Grep command line. Okay. We really want to see this install stuff right here. So I'm going to do that and then grep install. No, that's not helping me. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. That's it. That's it. That is all of the packages that I installed to build the Linux kernel. And in fact, some of these, and it's in the video. In the video, we needed to put in all this curses stuff just to get the menu config to work. That's in the video. You know. Then we ran into, right, the libSSL stuff, the libelf stuff, ran into problems there. Then I ran into a wonky sort of interesting error. Yeah. Payhole. I ran into something so wonky that even another guy who's pretty senior Linux guy, he and I were talking about this, and we both said, where did this come from? This is new. We haven't seen this dependency before. Well, I've seen it before like once, like, I don't know, 5 or 6 months ago. He was asking me, am I doing a cross-compile build? I said, no, it's not cross-compile. It's 100% AMD 64, AMD Opteron technology. He thought, well, why do we need that? I said, I don't know. But I can tell you this, we're not going to get the job done if we don't install that stuff. So, right here, I think this is it. Yeah, there we go. At the very, you know, we're getting to the end of the whole process of where, you know, VM Linux, there we go, right? We're getting to the point where our Linux kernel is basically done. And then it says to me, boom, you know, Payhole is not available. What? Anyway, I had to install, are you ready for this? Are you sitting down? Do you have a beer? I had to install dwarves. I had to install dwarves because dwarf is the name of the format that's used to store debug information. And dwarf 3 and dwarf 4 are now very real things. And in order to handle dwarf debug data, you need dwarves. You just know that the Unix and Linux people, they're all a bunch of wizards, right? It's like dwarf, elf, right? There's elf right there. Yeah. This is all you need, though. This is it. Actually, from here down, put in curl. Put in curl. I think curl is essential. I've hit that point after enough years where I just say curl is essential. You need curl. And then this stuff here, I'm gonna have to document this and write this up someplace, but okay. So that's the software that's needed, and it's needed because up here you can actually see me flailing around in the timestamps. Let me see, this is 11 o'clock, putting in the SSL dev, 2.5 minutes later, put in libelf, and then everything's going great, and then it blows up. An hour later, the process stops. I decided to put in Linux headers, but that was wrong. Linux headers, you don't really need this. You need dwarves, right? And then 4 minutes later after that, I put in Git. But Git I only put in because I needed it for something else. So there you have it. The stuff you need to build the Linux kernel is right there. Alrighty. The other thing is, what was the result? Well, let's go to lib modules here. In lib modules, let's take a look at the, bone stock off-the-shelf kernel. I just want to see how many kernel modules are down here. Over 3,000. Oh, almost 4,000. There's almost 4,000 kernel modules in the bone stock, baseline install of, say, Debian Linux or Dev1 Linux, Red Hat Enterprise Linux, CentOS. You're looking at almost 4,000 kernel modules. It's huge. I tried to trim that down a bit. So in the build that I did, in the last 24 hours, it should be down a bit. Yeah, 2,400. So 1,500, but basically 1,500 kernel modules are out of the process, right? That's a good start. It's possible to build a Linux kernel with very, very, very few modules. Only the stuff you need and nothing else. And if you need anything else, you're in deep trouble because you don't have the module anymore. If I take a look in /boot, look at the size of this initial RAM disk. Look at it, it's huge. I did build in a whole pile of kernel modules. I don't know, Zor, if you're still listening, but you were asking about, a modular kernel as opposed to monolithic. And if you watch the video that I did, you'll see that I ticked off a whole pile of stuff saying, oh, I need this, I want that built right in. Oh, I need this, I need that, I need this, I need that. And I just said, just build that right in. Well, I did. And we end up with a larger kernel. We also end up with a bloody big initial RAM drive, RAM disk. The initial RAM disk that gets unpacked into memory gets big. In fact, how big is that bloody thing? I wonder if that would still work on... Yeah, that's big. That's really big. And that's compressed. So, uncompressed, it's 700 and some odd meg. Wow. So this is, uncompressed, a 700 megabyte RAM disk. And that's just the initial, that's like in the early boot phase, getting your kernel in and getting an initial RAM drive that you can at least begin to communicate with the rest of the main system. Yeah, that's pretty big. Is any of this making any sense? Because we're going to move to another topic now. It's time to change topics. I mean, that's, the upshot of the kernel build is, you can build a Linux kernel. You can knock out some stuff. You can build in some stuff. And, you can be running the absolute latest and greatest. You can actually be running a release candidate, RC4, right there. You can run a release candidate that's not even released yet. But I'll run it. I'll run it. Okay, that gets us over to here. Time to change topics. Should I do a stop start? Should I just stop this, stop this stream entirely and then do a restart? Because from here on in, I'm just going to be messing around with software and numbers and, maybe some software cleanup that I haven't done in a while, and drinking beer. Okay. You think about that. I want an answer. I'm going to go get a beer. Okay. Hey, Cash 9. So what are we doing? We're doing a stop start? I think we're doing a stop start. Yeah, we're going to do a stop start. Okay. So there. I did follow up on the Linux kernel thing. We addressed, the topic of a monolithic kernel as opposed to a modular kernel. And it does raise the question of, hey, how about building, a monolithic Linux kernel? That's possible. Got to think about that. Could be dangerous. It's a good experiment, though. Yeah. Okay. Bear with me.